Hello everyone, my name is Franco Pucci. I'm the technical consultant for the STS Association. Welcome to Training Video Series 2, where we will explore the companion specifications. I hope you find these videos helpful. In this video, we will look at the STS600-4-2 companion specification. Please refer to the relevant document for detailed descriptions, and the document is STS600-4-2 Key Management System. This document specifies a key management system infrastructure for the Standard Transfer Specification, or STS, as contemplated in IEC 62055-41, Section 9 and Annex A, including all relevant cryptographic techniques, protocols, and data formats. The infrastructure is intended to standardize security module initialization and vending key transfer from a key management center to a secure module, to conform to contemporary standards for key management and cryptographic security such that the specified cryptographic techniques may remain in use until the year 2045. To enable secure remote coding of security modules to simplify logistical process and to support the STSA Code of Practice for the TID rollover, and that is STS COP 402-1. The security target for this system has been set at 128 bits for the whole system and 192 bits for key management operations, in accordance with Key and Algorithm Security Strength Recommendations by NIST SP 800-57 Part 1 and NIST SP 800-131A. All cryptographic protocols and algorithms in this specification are standardized by ISO and NIST. Algorithms other than those prescribed or constrained by 62055-41, like the STA algorithm for example, are approved for US Smart Grid Cybersecurity by NIST 7628 and meet or exceed the augmented requirements for US federal cryptographic key management systems. You can be sure that your keys and tokens are secure to the latest standards. Since this is a very complex specification, we will look at a much simplified version in this video. Please consult the specification for an in-depth look at the processes. So, if we have a look at the key management process, we have a secure module manufacturer, we have a secure module operator, and we have a key management center, or key management centers in fact. The first step that happens is that the secure module manufacturer generates a key pair for signing and sends the public key, the pub key manufacturer, to the KMC. This key is valid for between 3 and 5 years. The secure module manufacturer then delivers the secure modules to the SM operators. Step 2 would be KMC initialization, where the KMC generates a key pair for key establishment and presents the public key, that's the pub key KMC, to all SM operators. The validity of this key is 2 to 3 years. For SM initialization, you have a secure module manufacturer that manufactures secure modules, and you have multiple KMCs. So step 3 of this is the secure module generates a key pair for key establishment and gives the public key for that secure module, and that's pub key SM, to the manufacturer. This is used in steps 6 and 7. Signs the secure module identity and the pub key SM using the manufacturer's signing key, that's step 1, and sends the certified key to the KMC. Each KMC receives the certified SM public key and identity from the manufacturer, verifies the signature using the manufacturer's pub key man, imported in step 1, then stores the certified SM public key in the database. The vending key load and request and response we can discuss now. Whenever a security module needs new or updated vending keys from any KMC, The secure module must prepare a vending key load request that is sent to the Key Management Center. The Key Management Center uses the secure module's certified public key, which was imported in step 5, to verify that the request originated from an authentic secure module. Then replies with a vending key load response that authenticates the KMC to the SM and includes 0 or more vending keys. Let's have a look. So this is the process for the vending key load request and response. The SM operator loads a public key into the security module. So the SM is given a KMC's public key, and of course these will be different for different KMCs. That is the pub key KMC by the SM operator and generates a VK load request, which is sent to the KMC by email. That is step 6. The KMC finds the public key SM, authenticates the secure module, generates a VK load response containing 0 or more vending keys, and sends this to the SM operator, and that's step 7. The document gives an in-depth explanation of data types and encodings used, cryptographic primitives, data formats and structures that are required, SM manufacturer and KMC setups and initializations, key compromise procedures, in other words, what happens if one of your secure modules either gets stolen or a key gets compromised, what do you do in that case? The structure of a VK load request and response, and several examples. Please refer to the STS600-4-2 document for detailed explanations of all the required functions and data formats. Examples of the key agreement scheme and samples of the VK load request and response are discussed in video 4 of series 1. Let's look at a few of these structures. The VK load request is of record type VK load request .1 with the delimiter field a delimiter between fields, which is a vertical bar. In position 1, you have the IDSM, which is a printable type, and in position 2, you have the ID of the KMC, also a printable type. In position 3, you have a time variable parameter, TVP KMC, which is a timestamp type, and it's a time varying parameter taken from the secure module's real-time clock. In 4, you have the hardware ID, and in 5, the firmware ID. And the hardware ID contains the SM hardware model and revision, and the firmware ID is the SM firmware application and version. Then you have Q hex, 194 hex characters, which is the secure module's ephemeral public key, QE. And lastly, position 7, you have a message authentication tag. PKID is a record which is maintained by the manufacturer, and it actually links the manufacturer's secure module to the public key. Do you remember this explanation we did for a VK load request from video 4 of series 1? You have a beginning and an end. Then you have a record type, which is a VK load request .1. Then you have the ID of the secure module, which is SMID .1 record in red. You have the ID of the KMC, which is a KMC ID .1 record. Then you have a time variant parameter from the secure module, and this makes sure that VK load requests are always different and they are time stamped. Then you have the hardware ID of the secure module that generated the VK load request. You also have the firmware ID in green of the secure module in question, and all of these would have been recorded at the Key Management Center when you initially set up the new secure module with the KMC. And then you have an ephemeral public key for that module, and right at the end you have a message authentication code, and finally the 150E at the bottom there is just a CRC to make sure that none of the data has been played around with during transmission. The VK load response is of record type vkload.resp.1, again with a vertical bar as a delimiter. There you have the ID of the KMC, the ID of the secure module, a time variant parameter of the KMC, and a message authentication tag. And again, PKID is a record with delimiter that identifies entity A by binding together the unique name of entity A with A as public key. The vehicle load response obtained from the Key Management Center is KMCID.1. The record type is vehicle load response 1. The KMCID is the bit in red there. Then you have the secure module ID that requested the vehicle load response to be generated. You have a time variant parameter again when the vehicle load response was generated. And you have a message authentication code at the end. Then you have a set of key records. You could have one or you could have many key records. In this case, it's showing one, and within those key records, you have all sorts of key attributes like activation date, base date, credit limits, currency limits, key check values, etc., etc. These were discussed in other videos in Series 1, so please have a look at them if you want more of an explanation on these. This brings us to the end of this part of the video series. I hope you found this video helpful, and I hope to see you for the rest of the video series. Goodbye and see you again soon.